Hello folks, it's time to do a Harrier CB that during transit no longer says Harrier CB. So we'll get that glued on at some point. The only glue we recommend is Bostik. There's a knackered one. So we'll put that safely until later on. This one needs a power lead. Comes with a power lead stub, and the connector is, I think, best described as knackered. We bought this off eBay. It's for 23 quid, which is nice. And he prefers to do this than a new radio, which is a fair comment. Okay, so the screwdriver, I'm hoping it's just a retune and test. Makes it cheaper for the customer. I sometimes get inquiries in the comment section on the videos asking about could they email me about a possible repair and that. The email address is clearly shown in the about the channel, so it is in there. Right, let's see if there's anything there shouldn't be. You know what, it still smells of newish radio, that. They're fun to get to. Now we've got a scrap Harrier, and I'm just hoping it's got that. That's an avalanche of stuff, and you can see why it came like this and it's got a knackered PA, and it's had work before, so I decided enough was enough on this and suggested not proceeding with it. You know what, I think we'll probably start by doing this. It might be better to get to it if first remove the extension speaker socket. Good practice to put that hardware back on there. You never know, we might need that. Just unsolder that capacitor. There we go, that's made it a little bit easier. So we've got a screw on the side. Cut those wires off on this one. So this is the shield plate to anchor the ceramic capacitors here, which are there as decoupling. So hopefully we can push that out now. I think we'll release the other screw. To get rid of the whole screening thing. What I don't want to do is snap these tabs off. Well, it's out. Be easy taking the customer's one out, won't it? Take his power supply stub out. No, he's got a later version. He's got a nut on this one, whereas ours was done with a pin drive. Sorry, his is done with a pin drive. No, this is his, that was ours. Ours was done with a pin drive. So I'll return the hardware. So unsolder that. That decoupling capacitor he showed in his photo has come away. Next decoupling capacitor hasn't. That's it, gets us down to the socket. You know what? It's still not easy to get it out. Oh. So it's negative to the right. That solder went on my leg and I'm wearing shorts. We'll cut that off there. So you can see the tabs snapped on that. And this has been certainly messed with. Right, well, let's clean that up somewhat. So I wanted to put the wires through the holes properly and not just tag them onto the edge. When we're soldering, it always wants to be a good mechanical join. So I played the organ for a wedding today. I have to admit to having had to lie down after that. It's not just the 40 minutes of the service, it's all the hours of practice behind the scenes. And you know, it's not just, I don't just turn up and it happens. And this one wanted a piece I don't normally play. I've learnt it before, but I've not played it for 20 years, so you know, you've got to brush up on that. That's that one. It's just this one. Just easy to put in, hard to take out. So just neaten that up, just like that. So, have we got a better capacitor? There is enough on that one, but there may be more. On the donor, if I can only find the... Where's the bit I took off? So let's unwrap that. So that's our first capacitor. And our second capacitor is still in place on this earthing bar with a snapped leg. So what, we'll cut that one off and recover another one. I think the printer's going to do some printing. What's Mr. Chippy up to? What's he printing off, do you think? Right. There we go, so we've got two ready to go back on. We'll screw the earthing bar back. You know, it's a good 20 minutes to do this. Right, that's soldered in. So now that one can go back onto there. And that one can go onto there. Now I can't wrap these round, so again, what I said about a mechanical joint isn't going to happen just there. Drops the washer inside the radio. So the plastic one is on the inside. So it's isolated from the chassis, because these sets are a floating chassis. Right, so we've done that. So all we're going to do is make sure it powers up. We'll use this stub, so we'll be providing a new power lead. So that's spent as long as it would take to do a whole tune-up on this so far. And there we are, lit up. Alright, we'll connect it to the test instrument speaker. And we'll use our standard replacement mic. There we go. Picture in picture on. Key up. And discover we're not plugged into the test equipment through the aerial. So it's doing 3.2 watts. then on channel 40, we're not even showing you the right bit. What? It's frustrating, all this. Everything's always frustrating when you press buttons and it doesn't do what you pressed. Okay, back on to this. Actually started raining. I want to really get this done within 15 minutes now, so we can get an on-the-air test done. It's getting dark. We're approaching 7 o'clock. It's last day of September. So put it on channel 40. It's on channel 40, and we'll check the VCO voltage for 4. It's the far side of resistor 4. 3.83. I'm not going to touch that. That's within where we want it to be. And then on transmit, it should also be 4. And it's 4.09. So we're not going to touch it. I've done this time and time again. So the transmit one for 4 volts is the red trimmer there. The receive one is the coil there. We now have to verify it on channel 1. Should be somewhere around 2.2, 1.8 to 2.3, somewhere like that. So there we are, 1.8 to 2.3 on receive and 2.09 on transmit. So it's not often that I don't have to touch that at all. Good. Well, that's something that's spot on. Let's see whether we can get 4 watts out of the transmitter. Pop it back onto channel 20. Make sure picture in picture's on. It is. So where have I? You know what? I've come back and realised that's where the remote is. We'll put that on the right camera. So it's 4 volts plus 4 volts, 4 volts plus 4 volts. I can't remember whether we checked the other channel, so I'll just have to do that again. 3.5 on channel 40 and 3.5 on channel 1. Go. Right, so you can find the right trimming tool. The answer was, of course, it was on the floor. Okay, transmit, channel 20. So that's our peak, slight adjustment there. There's our peak, it was correct as it was. And there's our peak, which was correct as it was. So we've got to quickly put these to maximum. As I've said before, it can't support the kind of power that it's going to produce for very long without damaging the set. So, some sets you tune in for maximum and they will never do 4 watts, and that's fine, but this is designed to go to something near 5 watts. Not to use illegally on 5 watts, but so that it balances well. It's a good design, and then you drop the power back. So peak 4.3, .4, 4.8. Check that, these two again. It's all interactive, this. Yeah. Right, then we go forwards clockwise with the yellow one for 4.4 watts. and then anti-clockwise with the green one. The manual says for 3.8 watts, but considering we're allowed 4 watts, and unlike the manufacturer, we haven't got to get the set through customs, we have it to a full 4 watts. So, see what it is on channel 40. It really needs to be within 0.1. Spot on 4 watts on channel 40. Spot on 4 watts on channel 1, so that's worked out well. So, not only have I done the job right, but the radio is performing really well. So, make sure the meter reads 4. Well, of course, it's swinging across, telling us lies. So remember, this is only relevant into a dummy load. And I've said and shown before, and plug an aerial in here, and it may only just move the meter, it may bang across, it's still doing 4 watts, because the meter is relative to SWR, etc. So that's that. And now we're going to check the deviation. First of all, I want to put, we'll just check deviation first. Wow, it's actually 2.7, it's a bit high. So, just fill a bit more of this in. So, 4 watts, 4 watts, 4 watts. RF meter was showing 6, it's now 4. And deviation is reading 2.7 kilohertz, which is too high. Let's deal with that. So I want the one on its side in a particular position. Right, so that's where I want it. And now we'll do the deviation on this one. Wow, that's now correct. Now, because I can't trust this deviation meter on the Marconi test set, because it's got capacitor issues, and we haven't time to do it because I can't afford the downtime. We'll just plug into the instrument behind me to verify. Voila. That's too high. So in actual fact, I bet it was about 4 kilohertz deviation. Voila. Voila. Right, we'll turn that instrument off. Yeah, some people seem to like to be heard on 3 channels at once. You know, they moan about particular sets being prone to bleed over, but when you've got deviation like this, it's the transmitters are causing the bleed over. So that leaves 2 things to do on what to do the frequency. So let's just show that. Camera 2. So it should be 27.79125. I'm not even sure that's going to adjust. We may have a Duff crystal. 27.78781. Absolutely miles off frequency. No, it's not going to go. So it's got a Duff crystal. It's like a third of a channel out. Customer could have done without this expense. Now we've got some dead cheap Chinese ones, which I can never get to. I'll rephrase that. I can rarely get to work. They all seem to be out of spec. It'd be good if we could use one of those. It would be cheaper for the customer. cut the power off. You know, this is it, when you're in a real push for time and then this happens. So this set would have been unreadable. It's that far off frequency. That's no good. We'll try a few of these. It's about as bad as what's come out, to be honest. No. There are some things these do work in. I'll probably have to try and order 10.245, and then by the time I find that the 10.24 when they get here, you know. We'll have to look for something on a scrap set. Now I've got this American AM set here. No, I thought this was going to be really straightforward, just a tune-up. I'll have to look at what the eBay listing said, because if it said it was working, well, it wasn't, was it? But of course, if it said it was untested, that's fair enough. So that's about a 1979 American set. So chances are this is quite a good quality crystal. And that's why it's still useful to beg, steal, borrow and buy even sets that are illegal in the UK, because they're still useful parts. The fact I've soldered this is going to affect the frequency it produces, so I will have to come back to that. So just as a temporary thing, we'll put the bottom on because it does have a capacitive effect. Just put one screw in just in case that needs changing again. See whether we can get it anywhere near. The answer is no. Won't go far enough. Anyway, what we're going to do, we'll do the rest of the set. So I'm going to adjust the signal generator to be off frequency. I was hoping with that being a higher quality crystal it might not have dropped as far, but there you go. So I'll set this to go back to transmits. We've got 27,79068. So we'll set the receive to 27,79068. Well, 3. Actually, it was minutely out. Let's see what the sensitivity is. I should have done this first. So 12 dB. It is 0.34. For 20 dB, it's 1. For 10 dB, it's 0.3. So it's absolutely fine. It's supposed to be under 0.7, so it already is under 0.7, but let's see if we can get a bit more out of it. And the answer, yeah. I'm not going on here. I'm supposed to be showing you the SINAD meter. Next one. We're spot on. Little improvement there. Put a bit more signal on for the next one. Fine, done. So we want a new reading. 12 dB. We've now got, oh, we're on the wrong scale now. For 12 dB, we've now got 0.22. For 10 dB, got 0.2. And for 20, we've got 0.7. Squelch. Let's turn the squelch to maximum. I like them to be 100 microvolts to come in, but there's no hard rule about it. Let's put over to the attenuator. Camera 6. So we're at 1 microvolt at the moment. I've set the radio to full squelch, so 3, 10, 30, 100 is exactly where I want it to be. So it's already correct. So it would be that preset if it wasn't. While we've got 100 microvolts on, we'll set the S meter. At the moment, it's a little bit lazy. Let's give you a reading so we can write it down. It's actually 300 microvolts. So we'll put this back to 100 microvolts and adjust this till we get S9. There we go. So remember, only S9's ever calibrated. Now threshold. So signal generator to standby. Radio's squelch to threshold. And it's 2.7. So it's 0.27. No, it's not. Yes, it is, but I want to use the other scale. 0.7. Current consumption on transmit 1.029. I forgot to take it before. And on low power, let's go over to the main meter on camera 1. It's 50 milliwatts. What can happen is these presets can get dirty. So give it a little spray with Servicol switch cleaner, waggle it around a bit. .400 milliwatts, which is where it should be. That was 4. So all that leaves us to do is to sort this frequency situation out. If the customer was absolutely skint, we'd let that go, because it's not illegally off frequency, but it could start to become noticeable. Mind you, we get some new sets with unadjustable frequency which are no worse than this. So I said that wrongly, didn't I? Which are no better than this. I'll have to go into our storage shed, and it's pouring with rain, and that's 100 yards away, so I'm not going to do that. So we'll do it on the air test. I'll sort that out later. You know what I'm doing. And then at least we can get this done. I've only got one church service tomorrow on Sunday, and that's unusual. It's 9 o'clock, so I'm going to do tomorrow's repair, which is going to be a base station. It's been here before, something's gone wrong with it, so it's not going to be very extensive. It's just going to be sort the problem out, which is, I think, is intermittent transmits. Either a Harrier CB HQ or a Harvard H407, I can't remember what he said now. So I think it's going to be the trimmer capacitor in the VCO, so it would be like that red trimmer is there. Anyone know where I put the lid to this? So I'll just put one screw in the lid, one screw in the bottom. We'll get on the air test. It's not far enough off frequency to affect performance, and it certainly isn't illegally off frequency as it was as it came in. The trouble is all the crystals I'm putting in are also 40 years old. But we have got some other sets. I want some glue, which is also going to be probably across in the organ workshop. Don't think there's anything left in this one. No. Just for the aesthetics, we'll plonk it on looking nice. So we'll put the aerial on. See if anybody can be heard. One Anna Roger. We're on low power, not going to hear me on that, are they? $19 Roger. Notice it says 3 when we set it to 4. It's what I was saying about it making a difference when we set them on a dummy load. Foreign interference. Okay, talk to Mr. Chippy on that, doing on the air test. Turn that off. So, thanks for watching the Harrier CB repair. So I've just got to do that to crystal, but we're doing on the air test right now.